Here we're going to be looking at, analyzing one of the salts for the coming exam. In this exam, we are given two salts. One of them is triazo. One of them is lead triazonitrate 5, and we are going to be analyzing it. That is, the first one is C, which is lead triazonitrate 5. Lead triazonitrate 5. Now, based on this and the information and the requirements given to us concerning this exam, what we have here, we are likely to be testing for lead. We're likely to be looking at lead, and the other was based on the requirements. You notice that we don't have conc tetrasulfur acid there, and we also don't have iron 2 sulfide, which we normally use for brown ring test. So for that reason, there is possibility you might not be identifying this nitrate. There's possibility, even if you don't want to carry out brown ring test, the other test that can give you indication that we have something like this. We don't have copper tonics there, and then we also don't have conc tetrasulfur acid, because I know that whenever you put any of the salt that contain nitrate, if you add copper tonics and conc acid and heat, you find out that there will be brown fume coming out. This brown fume indicates the presence of this. It's likely that we have nitrates. Nitrates is a nitrate salt. So all these things are not there. So possibly, from what I'm seeing here, we're not likely to be looking at this. So the only analysis I'm going to do here is possibly how to identify lead. Based on what we are given one, we have dilute hydrochloric acid there, and we have sodium, dilute sodium hydroxide, and we also have aqueous ammonia. These are two important reagents in identification in salt analysis, when we're identifying cations in a salt analysis or qualitative analysis. Now, so let's start. Let's kick off. The first thing we have here, we are going to be doing is mainly, if you know very well, mostly we do the solubility. The solubility test, that is adding it to water, C plus what? Distilled water. Then stir and divide into what I'm taking. I think let's go by 3 portions. 3 portions. Divide into 3 portions. Divide into 3 portions. When you divide it into 3 portions, then what we have here, adding water to it, you find out that it's soluble, giving us a clear solution. What we have here, soluble, and what gives a clear what? Solution. A clear solution. So that is what will give us a clear solution here. So now there's something about having a clear solution. One of the things, when you have a clear solution there, it means that transition ions are not present there, because most true transition ions always give you what? Color, because of the presence of the block. So in this case, since we don't have something like that, it means that this portion does not have any transition ion in it. So what we have here is soluble salt. You can say soluble salts or soluble ions. Look at soluble ions. Then there are a lot of ions that can be there. Some of them is potassium ion, which is always soluble in every case and give you clear solution. And then we have also sodium. These are soluble ones, very soluble in it. So potassium, sodium, and even ammonium ions, they are all soluble. You can also put them there. That's I say ions like Personally, most time I like doing it this way. Like what? Potassium ion, sodium ion, and what? Ammonium ions likely present, because we know it's not there. At least we are not sure of the one that is there, but we know that these other ones are very, very soluble in every case. They are very, very soluble. That's why I feel that adding them might not be a great issue. So now the next thing is that we are going to be working on another thing we can put here is also transition ions. Not present, or we say absent because of clear solution. Transition ions are not present. Transition ions are not what? Present. So you can just decide to put the word soluble ions present. Soluble ions present. But if you say soluble ions present, it means that you're trying to generalize that every ion that is soluble is here. There are some other ions, just like there are some other ions that are soluble in some cases. Soluble in some cases. Some of them are also soluble in some cases. So, but then, so let's continue. So we can also say soluble compound or soluble salts, soluble ions, soluble salts. All these things can work in here. So going over to the next one, to the first portion, to the first portion, what are we going to do here? What we're going to do here is to add sodium hydroxide, dilute sodium hydroxide in drops, then SS. So in drops we have white precipitate. White precipitate. The white precipitate is always insoluble. Insoluble in SS. Insoluble in SS. So if we have white precipitate that is insoluble in SS, so we have some ions that can give us something like that. Some ion like calcium ion and lead ion likely what? Present. They are likely present. Calcium ion and what? Lead ion, they are likely present. These are the two ions that can give you this. I can put all here, likely present. So the next one we'll go over to the next question. Now I want you to know something, because I find out that lead being amphoteric does not really give us a gelatinous precipitate like what we have in aluminium and zinc, which is also amphoteric ions, because you know what they do. These two of them is what? Aluminium and zinc. They give you gelatinous precipitate that is a kind of jelly-like and then very light, and then most times they float. But this other one, lead, what it does is that once you add sodium, dilute sodium hydroxide in the solution in drops, you find out that to be as if it will not go down. After a while, all of them will just gradually go down, meaning that it's not a gelatinous precipitate. So what we have here with lead and sodium hydroxide is always what? White precipitate. The cloud will just form in the top and gradually go down and then mix up. You have the white precipitate or cloudy precipitate, white cloudy precipitate in there. So we should know this. So the next one we're looking at, the next question, the first the third or second, the second portion, the second portion, we add what? Aqueous ammonia. Aqueous ammonia in drops, then SS. In drop, then in SS. What we have in drops, we have white precipitates, then insoluble in SS. So being soluble in SS, what we have here is lead ion, likely what? Lead ion likely present. Now we are coming out, this is more like eliminating the two of them. Elimination, I don't know what they call it, the elimination method or whatever. So you notice that, because now why are we going down to lead? Because this other one does not show any reaction with any kind of precipitate or reaction with what? Aqueous ammonia. This, but it's just this one that can do that. So since two of them can give us white precipitate with sodium hydroxide, these are the only one that can give us white precipitate with sodium hydroxide. So for that reason, since these two, we also know that this cannot give us any reaction with aqueous ammonia. Now we come here, we have white precipitate, and we know that this other one can only give us white precipitate with this. So that's why we come down here, eliminating what? Calcium ion. That means we're looking at this is likely to be present there. Since we're able to see that this reaction that could be here, we are suspecting two of them, but one of them show some sign. That means this other one is present. Now something I want to point out here. Note, we said that ions that are likely to be here is what? Sodium, potassium, sodium, and ammonia. And we find out that they have precipitate. These precipitates, one precipitate we have here indicate that these are not likely to be present because they can't give us precipitate. This cannot give us precipitate with this. This other one cannot give us precipitate with it, and this other one can also give us no precipitate with it because these other ones are soluble in every case. So we can say that they are not present based on that. So now the next one we're going to be doing now is that from the information giving us the instruction manual, we find out that we have dilute hydrochloric acid. So the next thing we are going to be doing with that dilute hydrochloric acid that we have will then be, with the dilute hydrochloric acid, let me clean up here. So with the dilute hydrochloric acid, we have the fourth one. We have so the third portion. We have the third portion. Third portion, comma, add what? Dilute HCl plus what? Heat gently. Heat gently. So, and then you can say allow to cool. But allow and allow towards cool. Allow to cool. So the next thing we are going to see here, when we add this, we will have white precipitates, soluble when what? Hot, and insoluble when cold. That confirms the presence of lead-2 ion. Confirmed. That is what we have. The 2 ion confirmed. That is, and we'll be able to get this one confirmed. That's what we have, because this lead chloride is always white precipitate. Note something, that lead does not have lead nitrate is one of the, or I think the only soluble lead compound. The rest of them are what? Insoluble. That's what you should note. So every other thing you talk about lead here is what? They are all what? Insoluble compound. They don't dissolve in water. Only this very one. So white precipitate, which is soluble, and all of them, all the compound of lead, they are insoluble, and when you heat them, they will be soluble when they are very hot, and when they are cold, they will also give you the crystals. That's one of the things. The next one I'm going to be doing here is to look at the second analysis. So the next one we're doing here, we're going to be looking at the second salt that we have. The salt is type D, and the first thing we're going to do here, I just want you to follow along, go along with me, and then at the end of the day, if you have been reading as in preparing for this exam, you will be able to tell, and even if you are not able to tell, at the end of the analysis, I will also let you know. So I want you to go along with me here while I'm doing this, and to see if you will be able to identify from our observation and inference what is likely to be the compound before I give you the answer. That will be a kind of test for you as we do this analysis. So we have D plus flame. What we have here will be, we observe that we have lilac color. So we have lilac color. So from this color we have in flame test, what we have is what? Potassium ion presence. In this case, you can also say confirm maybe, because there's no other this thing for it. Yeah. Let's go with that presence. Potassium ion was present. So the other one we have here, the next one is the second question. D plus what? Distilled water. And then plus what? You test with litmus paper. When you test with litmus paper, actually, to give us a basic base. So then, okay, there's a place where we can do this. Let's leave this litmus paper stuff here. Distilled water, then we divide into how many portions? We are going to divide into 3 portions. Stir, then divide into 3 portions. So what do we have? What we have, we notice that it will be what? Soluble. What gives a clear solution. For what it means here, since we have a clear solution, we have a soluble salt soluble salts, or we can say that D is what? A soluble salt. We can say D is a soluble salt. And just let's go by this because we know from observation it's soluble salt. So now the next one we're going to do to the first portion. So the second first portion to the first portion, what do we do with the first portion? The first portion now, what we're going to do there is to we can add conc SeO. Add conc SeO. Then, or we can also, this thing can be done with the solid sample. With the solid sample, I think it will be faster there. Okay, let's go continue with this. Add conc SeO. Then we have acidified potassium permanganate. So what we have here is that when we add acidified potassium permanganate, when we add it into the compound, what we notice that our observation will be here. On heating it, we notice that you can also bubble it. You can bubble it into it if you want. You can bubble, allow the gas to come out, and you bubble into this acidified compound. It will still give you the same thing. But what I did in the lab is to add it into. When I added what I did in the lab, I know that you can bubble it. As the gas is coming out, when you add this, as the gas is coming out, you bubble it into acidified potassium permanganate. Or you can also use potassium dichromate. We can use potassium dichromate. Any of them can do this. Now look at what the major difference here. This gas also, plus you test the gas with what? Litmus paper. That's something I want to point out here. When you test with litmus paper, litmus. When you add conc hydrochloric acid into it, one thing you will observe here is that a gas will start coming out. That gas that will be coming out will do what? With litmus paper. Now, based on what I did, I added everything into it, but I know that one of the ways you can do this is to bubble this gas into any of this. When you bubble into it, you get the same effect. Now, what I did, based on what I did, is that I just add acidify. I use potassium dichromate. Potassium dichromate is what I did. And when I saw this, I didn't bother going for potassium permanganate. Once I noticed that it turns this one, what you notice if you are using this either bubbling or adding into it, if you bubble into it, notice that this one will turn from purple. Potassium permanganate will turn from purple to what? To colorless. So if it's this one you're using, you find out that it will turn from orange to what? To green. Then when you test the gas that are coming out with litmus paper should be damp litmus paper. Damped litmus paper. Note you always do it with two of them, red and what? Blue. Red and blue. When you do that, you will notice that it will turn blue litmus paper. Blue litmus paper will be turned. Blue litmus paper turns what? Red. So what we notice here, turning any of this from this, turning the first one, this potassium permanganate from purple to colorless means that is a reducing agent. Is that okay? Reducing compound, reducing agents is what we have there. This other one also, turning from orange, what am I doing? Orange, yes, orange to green. We also have, what we have here is what? D is what? A reducing agent. A reducing agent. Turning blue litmus paper to red means that it's acidic gas. Acidic gas. So the next one we're going to do, we have done with our first portion. Okay, we should have done it 3 portions. The next one, okay, I know why. Because I put this thing together. If I had done this one, we'll have this. If I did this one separate, we'll have this one. If I do this one separate, we also have this. That means we'll use the 3 portions. So what we are doing here, I'm just trying to, save a little time. So combining this here makes it easier, so that the time we can save time in this analysis. It's best like that. So now coming over to this end, what we have in the instruction manual or paper, we have barium chloride there. So what we have in the next portion, so that means we are going to stop at what? Just we did the first, second, this is fourth one. So the second portion, since I've already shown you what you are likely to expect, second portion in the third portion. So there's no need going over to that one again. So in the second portion now, what we'll do here is then we add what? Add dilute barium chloride. Or we add dilute chloride then plus what? Dilute HCl. So what do we have? When we add barium chloride, we have white precipitate. Then what else again? With this dilute hydrochloric acid, we have what we have is soluble. Now there's something I did not tell you here. When this gas is coming out, the gas is always has a kind of pungent smell. Actually, that pungent smell, you see that this pungent seems to be trending. Pungent smell, but actually, it smells like burning matches. It smells like a burning matches. The smell of this gas is what? Pungent, and it's also colorless. Colorless, I did not indicate that. Colorless gas. Now, since we have a gas that can do this, and it's what? Colorless. So we said, and turn this one, potassium permanganate or potassium dichromate, to what? Potassium permanganate colorless. Potassium dichromate makes it from turning from what? Orange to what? Green. It says what? A reducing agent. Now, coming over to this place, having white precipitate here, having white precipitate with barium chloride simply means that we're likely to expect gases like let's leave this gas. We're talking about the ions. Ions like this, triazo carbonyl 4 ions, and we can also be expecting what? Triazo sulfate 4 ions, and or what? Triazo sulfate 6 ion. So when we have this, since it's this, we can also look at having sulfide ion too, something like this. But then let's leave it in this one. These two, that's very, very common. These three, that's very, very common. Now, on adding, when you have dilute hydrochloric acid, what you have here is that notice that is what soluble in what dilute. Whatever am I writing? Soluble already. I've done soluble. What we have here, what's that thing? So we have is soluble here. So what we have in this inference, sorry, I just missed something up. Sometimes our brain will just be very working faster than what we're doing. So since we have soluble, what it means is that one, we have confirmed. Now this one is insoluble. This is insoluble, but these two is soluble. These two, they are soluble. If these two are soluble, but this one does not have smell. But we have a smell here, like I told you, is pungent. But naturally, if you are used to lighting matches, you really know that the smell that you're getting smell like a burning matches. Is that okay? That is to say, since is giving us a smell and it's a reducing gas, and this other one is not a reducing agent, as we know, it's not a reducing agent, then we know that this one is a reducing agent. That means this is insoluble, making this one not likely to be there. This is soluble but not a reducing agent, making being a reducing agent here is eliminating this other triazo carbonyl 4 ion. I hope you're getting something here. So being a reducing agent here means that this is not likely to be this. Both of them can dissolve in hydrochloric acid, but this is not a reducing agent. So this way we know that it's a reducing agent. So that means this is what we have. I hope you are getting something. Both of them, all of them are acidic gas. They are all acidic. They are all acidic. This one is acidic, this one is acidic. Even this gas, when it comes out, is also acidic. So what it means here is that for the fact that this other one is a reducing agent, only reducing agent here, it means that the sulfur 4 triazosulfate 4 ion is what we have. Now if you look at that, I remember I told you, if you look at that, you'll be able to, even from here now, you can easily tell this thing. I believe so. You can easily tell the compound we're looking at, or the salt. The salt is just potassium. No, that is what we have. That's what we're going to be testing. Potassium is always give us that lilac color in flame test. For O level, it's just that this thing that we normally use in testing for it. And then this other one is always a reducing agent. It's a reducing, the gas is a reducing gas. That whenever you bubble it, I remember what I told you here. What I did in the lab is that I put the salt, add tetrasulfuric acid, then acidify this. I did not use this one, but I know once I got this one, I forgot about this, because I know that since this one is the same oxidizing agent, it's an oxidizing agent, I saw that the color changed from orange to green. I said, it's okay, there's no need going down to this one again, because if it's like this here, it must also be colorless with this. So what I did was I just add them together. Actually, it's even what I wrote here based on my analysis. Now, when you add it together, when I did that, acidify this, pour into the bubbles that are coming out here, automatically the whole solution there turns green, while the gas is still coming out. There's a effervescence going on, taking place there. Now, another way of doing it, mostly the gases, when you're preparing, when you're using a solid sample or even a liquid, once you add hydrochloric acid there, then you channel it, you put your delivering tube, bubble it into any of this, acidify of them, any of them acidified, will give you the same effect. It will turn this one purple towards colorless, orange towards green. Not that thing, that's just the thing. And with this litmus paper also, when you test it, you find out that blue will turn red. Whichever way it is going to come out, just take it off, because me personally, I just don't want to try to connect those things, keep the cork around and just rush it. I tried that thing to work like that. I say, okay, that's exactly what it's supposed to be. All right. So thank you so much for coming this far. And if you're joining for the first time, we want to encourage you to what? Subscribe. If you have any question, please, if you have any question, leave it there. I will look at it. Any question you want to ask based on this we have done so far, just leave your comment there. Leave your comment there. I will come to you. I will respond to it speedily. So share and like so that you help this video now to go far. The more you like it, the more you comment, and obviously you help our video to go further. Thank you so much once again.